It is very nice to see you all, and you are so very welcome. My name is Carin Klaesson. I'm from the Nobel Prize Museum in Stockholm, and we are so happy for this Q&A together with you. And this is all supported by our Nobel International Partners from ABB, EQT, Scania, and Stegra. We welcome our honored guest, Professor Andrea Ghez. You are so very welcome, Andrea. Professor Ghez, you received the Nobel Prize in Physics in 2020. And the motivation was for the discovery of a supermassive compact object at the center of our galaxy. And I mean, whenever you put the word galaxy into a sentence, it becomes very powerful and exciting. And I'm not even an astrophysicist, but you are. What was it that brought you into this world of galaxies and black holes?
Oh, it's always interesting to ask how you got interested in a certain area. And I guess my interest in black holes goes pretty far back, actually, in terms of just how I got into studying the whole field of astronomy and astrophysics. Black holes, they represent the frontier of our knowledge, how physics breaks down. And that was my original interest in studying black holes. And then it was an interesting circuitous path to get from that fascination with black holes to understanding, that the center of our galaxy might be an interesting place to look. So it's a zigzaggy journey, but in the end, it really became clear that the center of our galaxy is the best place to look. Galaxies are like these building blocks of our universe. So we can talk more about different elements of this journey in terms of what you guys want to speak about.
Was it an obvious choice for you, or was the surrounding sharing, or was it a bit skeptical? Black holes, how are you going to do that?
Oh, this is the whole question of how did we come to think about black holes? Why did this become the work that made sense? We already knew, we had great evidence for a certain type of black holes, low mass black holes. And that gave rise to the question of whether or not there was a different variety of black holes. And the normal black holes, I call them normal only because theory predicted them. We anticipated them to be the end products of how stars, really massive stars, evolve. And then looking at the center of galaxies, really unusual galaxies, there were phenomena that was so energetic that people started to hypothesize that supermassive black holes that are 1 million to 1 billion times the mass of the sun, might be the cause of the phenomena. And that then led to a much bigger set of questions that we've pursued. So there was a fair amount of skepticism about whether or not supermassive black holes existed in general. And then more specifically in galaxies that were much calmer than those that led us to think about these supermassive black holes in the first place.
Thank you. Leonie, sorry if I mispronounce it. You have a question?
Yes, thank you so much. Leonie is perfectly fine. Thank you for giving us this opportunity and taking the time. I have a quite general question. As someone who's won the Nobel Prize, you're obviously a very successful researcher, but I was still wondering, what does success mean to you, and what qualities of yours do you think make you this successful?
That's an interesting question about success. I guess to me, as a scientist, what being a successful scientist looks like is being able to identify an interesting question that you can solve today. So it's an interesting combination of understanding what an answerable question is, what an interesting question is to answer in terms of really moving knowledge forward, and whether or not you have the ability to answer it. And I would also say that, to me, being a successful scientist isn't about being recognized with prizes. As much as I appreciate this recognition of receiving a Nobel, but from a scientific point of view, it's having been able to identify how we move the frontier of knowledge forward, and where can you fit in this whole endeavor. I mean, if you think about where we are and what our knowledge state is, it's like poking at a wall and finding where our weaknesses are, where we might be able to make some progress, and what is it that interests you? How do you grab hold of that opportunity? I think it's interesting. I mean, the other way to that I think about it often is in terms of training students. In the classroom, we educate scientists, future scientists, by teaching the current state of knowledge. And we tend to do that by asking a set of questions with known answers. So students learn the material. And there's an interesting process of mentorship where we help students transition from answering questions to asking questions. So to me, that's people have become successful at being a scientist when they make that transition.
And that's a fine balance, isn't it? To as a student fit into an institution, a structure, and at the same time being a bit anarchistic when it comes to thinking and developing.
Right. Understanding the limits of the knowledge. So going from understanding the state of knowledge, which is really important, to understanding where have we made assumptions, where there might be opportunities to think and differently.
Thank you. Timo, you had or have a question.
Thank you, Andrea, for taking the time. Really appreciate it. It's a very exciting opportunity. And I was wondering, I feel myself, but also a lot of my study colleagues, they struggle a lot with like kind of focusing on their studies while there's so much geopolitical stuff going on. And like, I feel like the whole world is in so much turbulence right now. And then it sometimes feels really hard, to read the news and then focus on like your equations, and especially if it's a very like abstract thing. So I was wondering, you also as a physicist who works with something that I've sometimes maybe feels very distant to like everyday politics or everyday news, like how do you kind of balance like these two things?
It's a great question. I think it's one that I've never been asked before, but I have some thoughts about it. I think the training of how to think like a scientist is really useful in this moment where there's a lot of misinformation and a lot of thinking or processes that are, things that are happening that are really different than what we might expect. So as a scientist, I think there's a process that we learn to get curious when things don't make sense, to get curious and to look at our understanding, the facts that we have the best evidence for, and to really bring to bear that process of thinking and unpacking how we come to a certain argument. I find myself as a scientist, when I have discussions with colleagues that are outside science, that I've really come to the understanding that our training gives us a different way of thinking, a thinking that really focuses on unpacking things that don't make sense, sort of being analytical, if one might say, and really trying to understand from an evidence point of view, because we're seeing a lot of different arguments being constructed and a lot of different statements about what's presented as factual. And I think it becomes more important than ever for us to really question what's being presented. And I truly believe our training as scientists really brings a lot to bear in terms of how we think about this moment where the news tends to create fear. So how can we unpack that? It's also true that there's a sense of calm when you can proceed with what you can have impact on in the world. I guess that's the other thing I would say. And as a scientist, I guess what I feel that I can do best is to help students understand how to be critical thinkers. And that's more important than ever, is really to apply that critical thinking. So I find as a scientist that focusing on that process, both continuing to develop it in my own world, and to apply it to our context. And it's a balancing act because, of course, yeah, here I haven't thought through, so maybe I'll stop before I get myself in trouble with saying things that I haven't 100% thought through. But I have thought through this piece of the critical thinking and the get curious and absolutely look at the facts. And I think as scientists, we have a particularly we have a framework that offers something to the current climate. So as students, I think it's really important to continue to train your brain in that solid foundation of factual knowledge.
Thank you. So you teach students, but maybe you should train politicians as well.
In teaching students here at UCLA, we teach both students who are majoring in science, but also we teach a lot of general education classes. And I often feel that those classes are important in my field, not only because they capture people's imagination, but they and teach around why science and technology is important, but that critical thinking, that analytic ability to look at how do you build up an understanding based on well-grounded information, and to continue to be questioning about how well-grounded all the pieces, and to really recognize complexity. That things are complicated, and to distill things down into bite-sized pieces is often to not recognize the bigger context. And again, as scientists, this is absolutely something that is imperative to how we make progress.
We all need training in that, definitely. Leonie, please.
If I remember correctly, I think you are the 4th woman that ever won the Nobel Prize, I think. I myself am an engineer. I did an engineering program, so there were not a lot of women around. And so, this kind of speaks to me. And I was wondering, what role do you think that played in your career? Or maybe it didn't at all? Or do you think you have to face any specific challenges because of your gender in that community? And how did you overcome them?
So I'm the 4th woman to win the Nobel Prize in Physics. So the question of what role gender played in the development of my career, I mean, it's true. There's a certain context that you are educated and continue to do your work in. And one of the benefits of being not in the majority is you're already outside the box. And given that progress is often made when you push outside the box, and pushing outside the box often brings with it a certain level of skepticism. So I think the advantage of being socially outside the box, perhaps by one's identity as female, that you've been well trained in being outside the box. And that's, I find, helpful when trying to do things that otherwise you're facing a headwind around. I guess the other thing that has been pretty clear to me at some point when the numbers became lower or low enough, and it is interesting to ask at what point do you start to notice? Does it become, I guess the way I would think about it is to become important to balance in some way one's life. So at some point it became pretty clear to me that I was interested in a personal life that had more balance than my professional life. So I think for me that was one of the ways in which I mean, it happens naturally. It's not such a conscious thing, but in retrospect, I definitely see the things I've sought out to make my life balanced.
Thank you. Emma, please.
Thank you. Firstly, I just wanted to say thank you to all for this opportunity. So nice to see everybody. My question for you was, we're talking a lot about in society about AI and how AI is impacting society and us all. And I wanted to know a little bit about how it has impacted your work as a scientist so far and how you think it's going to impact future scientists in a few years' time.
Well, AI is a field that's under rapid development, as we can see in so many aspects of our lives. In my field, there's a rapid uptake of AI in the analysis of data, in the way we're all getting information, and so it's certainly having a big effect, and I think we're thinking a lot about the biases that it can introduce, understanding the way these things or these processes get trained, the training sets. I think that's the thing that we think about in my specific field. And I think it's something we just have to understand, to keep an eye on, and to see the development. I mean, to watch it, to both understand the opportunities and the challenges. I think they usually come hand in hand, and it's an evolution that one can't stop, and so one might as well be as educated as possible and to think about how to harness it, how to cope with it. It's here in the moment.
So is this a situation where scientists should be more profoundly involved in political lines when it comes to how to use this?
This is the interesting thing I'll just say about being a Nobel Prize winner, is that one is expected to have an understanding at a much bigger scale. So I'm an expert in my field, and this is one of the interesting aspects of becoming a Nobel Prize winner, is that there is the expectation that one goes out and becomes a spokesperson for scientists. So in a sense, this question is, how important is it for scientists to get engaged? And I absolutely think that it is imperative that those with two things. One is the knowledge set, the deep knowledge set, to really address the very hard issues associated with AI or any issue that's being asked, and also the ability to have impact, impact in a number of arenas, impact within your community, impact within the broader scientific community, and impact within the political system that can institute policies around development of technologies that have tremendous benefit, but tremendous risks. And AI isn't the only one. And of course, all these developments are very much international developments. So it's a really interesting question, both about the responsibility and who's in a position, both intellectually from a deep intellectual knowledge, leadership, and engagement point of view. So the simple answer is absolutely.
Yeah. Absolutely, to a complex world. Yeah. Camille, is that how you pronounce it? Yeah, please.
Hello, Andrea. So I'm Camille, an undergraduate student at Stanford University, majoring in aeronautics and astronautics. First, thank you so much for taking the time to share your insights with us. Your work has not only expanded our understanding of the universe, but also inspired countless young scientists, including myself. And as a Nobel laureate, your work has had significant impact. But were there times when you adopted your findings or even had to pivot your research direction? How do you know when to persist versus when to rethink your approach?
It's a great question of when you've tried something, do you persist because it's hard and there are barriers to overcome? And when do you pivot? And you don't always know. And because these problems are hard and it's critical. I mean, if the challenges were easy to overcome, somebody else would have done it already. So really digging deep to think through what are the limitations and what are the opportunities. So sometimes it's very similar to understanding the initial state of what is a good question. So what hasn't been understood. So when you hit a roadblock of along the lines of something you expected to be able to do, I think it's a non-trivial challenge to know when to dig deep and to think about the tool set that you might have to unstick yourself. And I think the process of unsticking is how do you intellectually engage with what's already known or what might be an opportunity to move forward. And when you can't figure it out, and sometimes it's almost like a homework problem set. When you can't figure it out, what do you need to do to reset your brain, to look away, in a sense? And sometimes looking away leads you to a new question, and sometimes it leads you back to the answer. I would say one of my most memorable instances of contending with this is as a graduate student. Actually, yeah, it's a common place where people focus and pivot a lot, because your job as a graduate student when you first begin is to identify that question that is both interesting and that you can make progress on, and you're developing your understanding of those questions. So for me, it was when I was an early grad student coming to school thinking I wanted to study a certain kind of black holes with a certain technique, understanding that there was an opportunity to switch the technique. And that technique was the promise was to study supermassive black holes, but the technology simply wasn't there So it was about looking at these galaxies that were very active. And so I had to pivot. And so I had pivoted once already with an opportunity. And then it was clear that the opportunity couldn't address the question. And so then it was an interesting question for myself around, do you pursue the scientific question, or do you continue to think through, here's a new technology, what other question can you address? And at the time, I decided that the technology was new, new enough that it could open new doors. And it was a question of what question was interesting. There were a lot of questions that could have been answered, or a lot of things that were new. And so for me, it was talking to people, reading papers, and it led me to thinking about star formation.
Julius, please.
Yeah, I just also want to start with thanking you, Andrea, and also the Nobel Prize Museum Committee for arranging this. It's a really cool opportunity. I think, Andrea, that you might, you were getting there with what I'm going to ask you also, which is a more general question about research in general. So how do you, because you've worked on this for, I think it was 25 years, is that correct?
I'm approaching now 30. Oh, it's exactly 30 years that this work has been going on. Yeah.
It's crazy long time. And I'm just I think the previous question also was a bit along these lines, but I just want to know, how do you structure your research, and how do you know exactly this is what I want to research, and this is how I'm going to examine, evaluate, analyze it through these types of labs or experiments? And how do you also know, as previous question, how to progress? And then when do you reach your finish? When do you feel finished? If you feel finished. I just because I am still a master's student, so I'm I haven't done research in that way. I'm just curious about how to structure something so that you know what you're doing is correct, and yeah, just what you want to do.
That is a great question. I think it's one that I'm always asking myself, that question of how do you know, it's effectively, how do you know how to proceed? And in academia, we have incredible freedom to ask, to set our research agenda. Of course, it is limited by what you can get funding for, which is really ultimately, or really underlying it. I mean, the real question is, can you find an interesting problem to make progress? I find myself constantly asking this question because the road isn't linear at all. The question of it's got a lot of layers to it, that question of how do you know how to proceed? And in my own career, which is actually the only way I can answer this question, because I don't think it has a set answer, is there's a piece of it where it's very much hypothesis testing, which is what we're trained as science to do. Is there a question that's really well defined, and defined in a way that you can set up an experiment to actually answer it? And the reason I like to pursue technology as a way of moving forward as one key axis is that often in answering the question that you set out to answer, I mean, sometimes the answer is surprising, but often in my own research, there's been in the observations a whole host of other questions. So this project that's been recognized started as a very small exploratory program. It was a tiny piece of my research effort because it wasn't clear that it was going to work. And so in a sense, it's been, in hindsight, because I don't think I could have, I don't think I would have framed this in this way going forward. you know, the way we're evaluated as scientists is can you create new knowledge? So you are kind of always looking for that next step. But I didn't see 30 years. I couldn't think that far forward, but I could think forward on a 3-year timescale, because that was what that was sort of the timescale of experimentation that that seemed reasonable at the outset of my career. You know, it's kind of like a PhD program or a master's thesis. You're thinking in quanta. So as an assistant professor, you're thinking, I have 6 years to prove my my success as a scientist. So that's a unit of research that one's really focused on. So not 30 years, but rather sort of a 5-year, 3 to 5 year time scale. And what I came in with was a successful theme of research. That's often how people come out of a PhD. They've successfully proposed a body of work. You've hopefully, and if you've had the opportunity to move forward, come up with an interesting answer, and that usually offers you the next step. So for me, it came out of star formation. And so there was I would say the backbone of my research program, which was in that arena. But I also knew that, part of the academic structure is it's really important to show that you have ability to advance in other arenas. So this was both the recognition that a question that I had felt was interesting earlier on that the technology wasn't ready for, and seeing that the technology was ready, it was worth taking a step to see if we could get there. And it got there far better than we had possibly imagined. I mean, I really hadn't anticipated that the question that was answerable in 3 years could lead to much more, both in terms of the backbone, and this is and again, this is a very project or personal experience, but I don't think it's unique. The process of scientific engagement where there's pushback and skepticism often it forces you to think, how can I do better along this line? And can this approach continue to solidify the question that you're trying to answer? So I'd say for me, the process has been, is there opportunity? And I guess when I, in a sense, moved away from the PhD work was when this avenue became far more scientifically productive. And it had opened up so many different scientific questions that it ballooned to an extent that I couldn't pursue all paths. So that was a huge opportunity. And these tendrils have definitely petered out. In other words, there's been constantly the need to understand, when given the resources that you have access to, has that come not necessarily to a productive end, but when are other things that are opening up or still ongoing more interesting and more scientifically productive? I think there are points in people's careers where it's not clear. Like that state of ambiguity and uncertainty, it's almost like there's a cycling of, I don't know if I would call it boom bust, but I don't think it's a linear path. But thinking too far ahead is important for a vision, but it's important to recognize that it's really not necessarily how the whole arc is going to go. So I guess my advice to students is to really think about the next chunk, and while If you have a bigger vision, fantastic. But that can also become very overwhelming. So to really pay attention, to what's working, what's not working. It's almost like the process of what to major in. Because often students can come into college or university and not know where they want to go professionally. And there's a process of taking classes and really paying attention to what's intellectually engaging, and then just taking the next class. I think research on in terms of a continuation of that process is really similar.
Thank you. Great advice, and perhaps goes for life in general, I'm thinking. Ashley, please.
Yeah, I'm very grateful for this opportunity to talk to Andrea and meet everyone else. I just started a new position in Stegra as an intern, and I work with engineers on a daily basis. And I think Stegra is a company of doing green arrow making. So I'm wondering, a question to Andrea is, how do you see the recent advancements in physics could contribute to sustainability industry, like our company, like green steel production, or like what's your inspiration into these subjects to like sustainability, or what could we do better to it?
It's a really interesting question at the general level of how can physics, if I understand correctly your question, how can physics play a role in all these large-scale industries or technologies where we're trying to make advancements? And I think there's so many examples. The first one that comes to mind, of course, is quantum computing. That's a field that really starts fundamentally in physics. I mean, actually, the Nobel Prize in, I think, 2022 recognized a lot of that work. And in fact, you can see in subsequent years, the recognition of artificial intelligence also looks at roles of very basic science, very basic physics. And I think this comes back to, why should we do basic research? Research that one can't anticipate at the outset what the long-term application is going to be. I mean, there are wonderful studies or examples that have been given, for instance, looking at your cell phone and looking at all the technologies that are used, and how the origin of those technologies are in physics that was viewed at the outset as relatively useless. So I think it's really important to look at and invest in fundamental research, and so often this yields really interesting technological advancements. And you can see there are fields that are just exploding today that had very little investment and, in fact, very little excitement. I think often looking at where the students go gives you a huge hint in terms of what's going to make progress in terms of clean energy, what's going to make progress in terms of computing. But sometimes you can't anticipate it at the outset. So that's where fundamental science becomes really important in terms of the long-term advancement in technology. I'm not sure I've totally answered your question, but I've given it some aspects.
Thank you. Thank you.
Zane, thank you.
Thanking for this opportunity. And I'm a student right now, struggling with my master's thesis. And I was wondering if in any point in your research you ever encountered where progress just seemed impossible, and how you navigated that challenge. Like, what advice would you give struggling students?
I guess in terms of having moments where you're struggling or not certain, that happens all the time. I think that happens. I think uncertainty tends to see that sense of struggling because you don't know either. I guess as a scientist, you don't know how to make your next step. And I think there's a process of learning, and I think it's a skill that we have to continually teach ourselves to be comfortable with discomfort, to be comfortable with uncertainty. And I guess my advice would be to get curious, and also to both look away to try to understand and to find pieces that you can make progress in. So in the process of doing a master's thesis, I mean, I can't, there are many ways in which both students struggle in general, and that I've experienced those same moments of uncertainty. What can you do to continue to make progress, to give you a sense of engagement, to stay engaged with the problem that you're thinking about or working on, and to give your brain the opportunity to think outside the box. I mean, this is where, the saying is your best ideas come in the shower. It's when you're not looking head on. So I would say give yourself a break. Understand that it's a really common state for both students and professionals. And one step in front of one foot in front of the other. Yeah.
Thank you. Amanda.
I'm Amanda from Switzerland, and I'm an engineer. Thank you very much, first of all, for this opportunity. I'm actually very excited. And I have two questions, but let's first start with the first one. At the beginning, you briefly mentioned that for you, work-life balance is very important. And I was wondering if you have any advice on that, because I feel that sometimes, I feel really happy and lucky if I, find a topic where I'm very passionate about it. But sometimes even being very passionate and having something that is fully immersive can be too much if we don't have a balance. I don't know if you have some advice for us.
At some point, somebody told me there's no work-life balance, there's work-life choices. And after spending a long time framing it as balancing, I've come to really appreciate that. I think, a lot of these pursuits require you to, in some sense, ride the wave when it's really interesting. And there are deadlines that are really important. So I think, in some sense, the balance in part comes from knowing when you just have to. I mean, you have to go for it. But you can't keep doing that nonstop. So I think there's a baseline of knowing that taking care of yourself is also a really important piece of that. Like put your mask on first before you can help others. And for me, a big piece of this has been doing something physical. So sports in one way or another. So for me, college, it was running, then it became swimming. But there's something about getting out of your head. We have a very intellectual pursuit, and somehow doing things that allows your, in some sense, brain to relax. And it's really important from a health perspective. But I think for me also a social perspective. It's an opportunity to engage with people that don't think about science all day long. Yeah, and that question of work-life balance has meant different things to me at different points in my life. So certainly in college, it meant having a good set of friends who you can go out and do things with. And for me, finding people that are sort of simpatico, who also work intensely and are very focused. When I had kids, work-life balance meant something entirely different because the non-scientific work took on a really different meaning. And I think having had kids was a hugely enriching experience, and it definitely forced me to be much more organized about my work, and in some sense to really pay attention to when you push or you're in that state to not get solely focused, that it will keep going, like to have the confidence that you can do both. And in a sense, we do this professionally all the time when we have multiple responsibilities. So in a sense, we always focus on the things that are most important to us. And so for many, many years in my recent, in the recent years, it's been all about that balance. But I think it's really important, and there's a feedback to use language of science and technology, that I've learned a lot about being a mentor from being a parent, and really rethinking things from a different point of view. So, a lot of how I've thought about education and my research has come from my own experience, but really seeing it, that development from your kid's point of view is also has been really educational. So in that sense, it's not just a balance; there's a synergy. And I think I've often felt that way about the things that I've done synergistically. Outside what I've viewed my work to be, that have really interacted very strongly, both from a social and intellectual point of view.
Thanks for answering this first one. I was just wondering, I mean, you accepted to be here tonight with us. Of course, I'm very glad because I enjoyed a lot listening to all your answers. But I was wondering if you had in mind something that you would like us to know, to communicate to us, because I mean, you came here knowing that there's like 10, 15 students to talk to, and maybe you have something that you really want to give us as a takeaway. I was just wondering that.
The advice I would give today and is to continue, sort of to try to think about life from three perspectives. One is how can I continue to pursue the things that I am passionate about? Two, how can I do something that might open up new opportunities, something I'm a little uncomfortable with, something I'm maybe a little afraid of, because that might help you discover things that you didn't know were interesting to you. And then the third is, how can you give back? How can you help others explore their opportunities and their own journey? I guess I have to say I love that you guys are engaged. I find these things really inspirational to do, just to see just the curiosity and enthusiasm of you guys. It's an inspiration to see.
Thank you. I totally agree. So inspirational, and we're coming to an end, I want to thank you all for your amazing questions. And thank you so much, Andrea Ghez, for your inspiring and enlightening reflections on devotion, passion, curiosity, and balance, for that matter. Such a pleasure speaking to you all, and thank you so much for joining us. Thank you, Andrea Ghez. Thank you.
Thank you.